Okay, this was 3-1 for practice. If you remember, in this chapter, what you're going to have for test number 1, there's really two basic ideas. Idea number 1 is this section 1, how to balance equations. Then, the rest of that, it's really weight problems, kind of the basic theme, and then some variations on the basic theme. And we got a real good start in this section last time. So we'll review that section 2 and then go on and pick up the new stuff. Okay, so let's go over to this one. And let's see what we're going to do with this. And remember, it's trial and error, and there's no one right way of doing this. Okay, when you look at that, Bruce, where would you start? What did you do first?
I think I started with the CL2.
Okay, so let's...
I got confused, so I just need a review.
Okay, so that means you're...
Yeah.
Okay, you started with the CO2. You could, but that's going to give you a problem. Let's try the CO2, and then we'll get to maybe a better scheme. If you try the CO2, Bruce, what did you do?
Well,
what did you put? You got to think of the smallest number that the 3 and the 2 both divide into, which of course is 6. Okay, so if you do that, now don't write this down because I'm going to be erasing it real quick.
Yeah,
okay? Because that gave him a dead end. Okay, so by your method, if you started with CL2, because you see, yeah, it's a trouble spot, what would you put here?
3.
Would you agree, Bruce?
Yeah. I'm just,
okay, you're trying to get 6 total, so he would have put a 3 there, and then you would put a what here? A 2.
Okay. I understand why it's wrong. Yeah.
Okay, well, hey, that's not going to be enough phosphorus. So that was not a real good starting place. That what we could do, we could say, well, if you wanted to use fractions, since we're on the mole level, if you're thinking mole level, but you're not going to end up with fractions there, that'd be really bad to end up with fractions. So if you try the 1/2, because 1/2 times 4 is 2, there's 2. Technically we're balanced, but it's really bad. It's not acceptable like good grammar, or poor grammar. We want good grammar. So you could take it at this point and multiply everything by 2, but no. An easier route to go. Brittany, what did you do first?
I started with the P4.
Okay, so tell me what to do.
On the other side of the equation, you need a 4.
Okay.
And then that finishes the piece, you put a 1.
Okay, so you put a 1 there.
And then 4 times 3 equals 12, so then I put 6.
Okay.
Okay.
Now, if you recall, if we go back, Bruce got us to here. You say, whoa, we can't have that fraction. How would we get rid of that fraction? What would we multiply that 1/2 by? We'd multiply it by 2, wouldn't we? Which would turn it into a 1, and that turned that into a 6, and that turned that into a 4. So your way would work, but it's more brain strain than what Brittany. She got lucky and she started with the phosphorus. Okay, are we all right on this one? Both routes would lead you ultimately back to that. Okay, now, this one right here, how should we attack it? Sarah, what would you do to get that?
I started with the... I'm not really sure if this is right.
Okay, just say it. There's no penalty.
With the rubidium.
Rubidium.
And, so I put 2 over there.
On the left. And you put a 2 there, then you put a...
1 there.
Okay. Then where did you go?
Well, I'm a little confused because there's 2 H's over there, so there's 2 H's over there, and there's 3 O's and 3 O's. No, there's 4 O's.
Would oxygen be a good place even to look at here?
No, but everything else is...
Okay, but you said that. Brenda, give her an idea.
Start with the SO2 and SO3.
Okay.
And you need, in order to have them the same, you have to put a 3 right there at the
Oh, wait.
SO2.
Okay.
And a 2.
Wait, let's just think sulfur.
Oh.
Oxygen's bad news. Because oxygen is here, 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 and here. start with oxygen, you'll go nuts if you're not there already. So, what can we do? If you look at the sulfur, then you come back over to here. Don't worry about that oxygen. That's a nasty place to go. So, Brittany, what would you do here?
A 1.
A 1. Okay, now, let's see. Let's think hydrogens. I would steer clear of the oxygens, and then we can always come back and do them last. So, look at your hydrogens on the left over here. Nicole up front. Tell me what to do with water.
A 1.
A 1. Now, we've put in all our coefficients. We have the lowest whole numbers possible, so that's good grammar, but now's the time to check. If you were in a hurry to check it, how would we check it? Russell, what'd you do if you were in a hurry to check that thing?
Just check the oxygens.
Yeah, just check the oxygens. And here's where you want to hold your breath, because if they don't fall into place, we get to start over. Okay. Look on the left. Meredith, what's my total number of oxygens on the left? 4. Okay, now, look on the right. Tanya, how many oxygens do I have on the right? 4. Bingo. We're good. Okay, but you can, if you have the luxury of time, you would go back and say 2 rubidiums, 2 rubidiums. Let's see, the 4 oxygens, no sweat. 1 sulfur, 2 hydrogens, 2 hydrogens. Remember, rules, hard and fast, carved in stone. Cannot touch a subscript. Okay? We don't want to end up with fractions, and we want the lowest whole numbers. And so we go through until we get the lowest whole numbers. Now, when you're playing around with this, you know, if just by chance it fell out to be 4, 2, 2, 2, you would look at that and you would simplify it to the lowest whole numbers. Are we okay on that? Okay, let me shift gears on it. Rubidium. Where is it on the periodic table? What family is it in? 1A. Everybody spot it? Okay, try and shoot me rubidium. Okay, if it takes on a charge, what charge does it take on? +1. Because if it takes on a +1 charge, has it lost or gained electrons? Lost 1. And if it becomes rubidium +1, what's it isoelectronic with? Kr, which is Krypton, Superman's planet. Okay? Now, we are a little review on that. Okay, let's take a look at this one over here. We got another one to balance. Okay. Should we start with oxygen? Bad news. Erin, what shall I do?
I started with phosphorus and then put a 2 and
Okay. If you put a 2 there, then you put a what here?
1.
A 1. Okay. And then where are we going from there? Hina, what would you do next?
I went with calcium, so calcium on the right side had 6, so I put a 6 right on the left
Okay,
side.
and that took care of that one. Okay, so phosphorus was a good place to start, because if you'd started with calcium, you'd still have to do some more work, because if you just started with calcium, you would have put a 1 and a 3. You see, then you'd end up with a fraction, then you'd be multiplying everything probably by 2, or you would be 2, to get there. Now, what should we do next? Should we look at hydrogens or should we look at oxygens? Where would you like to go? Hydrogens. Okay. So, Andrew, how many hydrogens do you see on the left?
12.
Okay, you see 12, and if I want to fix this up, Antonio, what do I need to do then?
Put 6.
Put a 6. Okay, now let's check our work in a really quick way. Let's think oxygens. So right now, on the left here, on the left, Steve, could you tell me how many oxygens you have?
12.
Okay, let's see, there's 12 here. 22 oxygens, a large number. Now let's come over here, so let's write that down so we won't forget. We got 22 oxygens. So we come over here, in this substance right here, Emily, how many oxygens do you see?
16.
Okay, we got 8 times 2, 16. Everybody see where she's getting at? And then we come over here, Nina, how many more?
6.
6, are we okay? Yeah, 22 and 22. Okay, now, let's come back over me the sum of the coefficients for the balanced equation, and you would say 11. Okay? Or if I said, in this equation, give me the coefficient for the chlorine, and you will say 6. If it says chlorine, they mean the chlorine, not messing around with there's some chlorine in here. They mean the chlorine. Okay, give me the sum of the coefficients for the balanced equation. Allison, you're going to say 5. Okay, 3 here, 4, 5. Good. All right, then we come over here. What's the sum of the coefficients there, Aaron? 15. Let's see, we've got 7 and 2 is 9, and 6 more is 15. Sounds good. Now, that was extensive review of section 1. And I know some people get this, even though they've never seen it before, it just seems like the reasonable thing to do. And other people struggle with it. And I can appreciate that. I was not one of the strugglers, but if I stepped into a music composition class, I would be a big-time struggler. I wouldn't tell one chord, one note from the other. So I can appreciate some people get it and some people don't. Like some people walk in music and they just know it. Okay, so let's get back here to the weights we were doing.